In a slightly more detailed example for the use of simple linear regression, here we're going to model the price of a car based solely on its age. In reality, of course, there's other factors to take into account, and that leads to the topic of multiple linear regression, but that's in a follow-on statistics course. Here we provide information from computer or software output. We're told that the value of the constant is 20 and that the coefficient is -2, and the coefficient of determination is 0.81. One thing I should have mentioned, we have it down here anyway, but the price of the car is modeled in units of $1,000. No one expects to get a car for $20, so the constant here then represents 20,000, and the coefficient -2 represents a depreciation of -2,000 for each year the car ages. So the first question is, what is the value of r? You'll notice I gave us the value of r squared at 0.81, which says 81% of the variability in the price of the car is determined by the age of the vehicle. This is a trap, by the way, if you get this question. If you take the square root of 0.81, you'll get r is equal to 0.90. But this is incorrect. The sign on the slope, here is negative, must match the sign on r. And square roots will always come out as positive values. So take note of that sign. The correct value for r is -0.90. Okay, let's move on to the next question. We want to write the simple linear regression model for the price of the car in units of $1,000. And we're going to write this model using the correct names for the variables. So we would write that the predicted price, and typically we would put a hat on that because we're predicting it. An observed value would be price without the hat. So we have price is equal to 20 minus 2 times the independent variable age. Now, we're going to use that model to predict the price of a 5-year-old car. Let's move this up a little bit. Well, that means we're going to plug in 5 for age. So we end up with price, hat, is equal to 20 minus 2 times 5, which is 10. So, $10,000 is the approximate average sale price for a 5-year-old car. Now, a 2-year-old car, we're told, sells for $17,500. We want to know, did the buyer pay too much? All things considered based on the age of the car. Well, let's see what the model says the proper price should be. Price is equal to $20,000 minus 2 times 2. So that's $16,000. So maybe the car was in pristine condition, but if it was just in average condition, then the buyer paid too much, and this could be quantified in terms of the residual. Recall that our residual is the observed price minus the predicted price. So the observed price is $17,500, but we predicted $16,000. So that means there's a $1,500 premium attached to the sale of that car. Now, there's one other question that you can get asked here. I haven't written it down, but I'm going to do it now. Number 5. and that is what is represented in context of this question. What is represented by the y-intercept equals 20? Well, the only thing that's left in our model, let's use the word price. If price is exactly $20,000, then that meant age would have had to have been 0. So that means the price of a new car right on the lot is $20,000. So typically in simple linear regression model problems, the y-intercept, and this will vary depending on the context of the problem, of course, but it'll either be the price of something that hasn't had any straight line depreciation, or in context of rentals of property or business space, the values of fixed costs are often hidden in the y-intercept. You may or may not get a question like that on the exam, but keep that in mind, that oftentimes the y-intercept does have meaning in context of the problem. And that concludes the series of videos on simple linear regression.